In this video, you're going to learn a little bit about the remainder theorem and the factor theorem. So the remainder theorem is the first thing we're going to focus on, and that is basically just a fancy way of saying that instead of finding remainder through dividing, that you can just get a remainder by plugging in the zero of the divisor, and vice versa. So if you wanted to find through evaluation, instead of plugging in a number into an equation, you could just divide and find its remainder. So we're going to work on the first section today, where we are going to find a remainder by plugging in that zero. So if you look at question number 1, if I wanted to synthetically divide, I would do this. I would find the degree, I would check that it's in order, I would line up the coefficients, put the 0 in the box. Notice that because it's x plus 1, I put -1 in the box. I do my synthetic division, and I see that I get a remainder of 8. Now instead, the remainder theorem says I don't have to do synthetic division. Instead, I say, here is my divisor, so that means my 0 is -1. So I'm evaluating an equation of x with -1 everywhere I see x. So right here I have -1 to the third, 9, -1 squared, minus 2 times -1, minus 2. You could plug this all into a calculator, or I'm just going to write down the math. -1 cubed is -1. -1 squared is +1 plus, or times 9 is +9. That's going to be plus a 2 minus a 2, giving me, those two come to 0. 9 minus 1 is 8. So what this just told me was 8 was the remainder. When I synthetically divided, 8 was the remainder. Proves my theorem correct. So for questions 2, 3, and 4, you're going to do the same thing. You're just going to plug in to find the remainder instead of using synthetic division. So in number 2, since the divisor is x plus 8, you are going to plug in 8 for all the x's. Number 3 and 4, I'm not going to tell you. You're going to have to do on your own. The next topic on the following page is the factor theorem. The factor theorem says that if the remainder equals 0, then the divisor is a factor, and the number in the box is a 0 of the dividend. So if you looked on our checklist from earlier that we made, at one point we want to find all the zeros of a polynomial. So this is going to help us find all the zeros of a polynomial by using this factor theorem. So let's see how it works. If you look at number 1, we're going to synthetically divide to just see if the remainder is 0. So I got to check my degree is 3. It's in the right order. So that means I can set up synthetic division. I'm putting 5 in the box because the divisor is x minus 5. My coefficients are 1, -7, 7, and 15. Bring the 1 down. 1 times 5. -7 plus 5 is -2. -2 times 5 is -10. That's a +3 when added down. Oh, -3. And that's a -15. By seeing a 0 in the box, that tells me, yep, x minus 5 is a factor. And 5 is a 0. So that's just one set. So we're going to start making a list. For now on, we're going to write the word factors. So we can list all the factors, and we're going to write zeros. So we can list all the zeros. So right now we know a 0 of this function is 5. Factor of this function is x minus 5. Now we know from discovery that the degree is 3, which means it's got to have 3 zeros. Right now I only found 1. So we're going to go on and find the other ones by rewriting what we're left with. x squared minus 2x minus 3 equals 0. Again, I took the degree 1 less than 3, and I put x squared, and I added an x, and I counted down. We learned how to factor this, so I'm going to factor this. An x and an x, I need factors of -3 that give me -2. That's -3, +1. There's 2 more factors. So my 2 more factors are going to go here. And each of these factors give me another 0. So x minus 3 gives me the 0 of 3. And x plus 1 gives me the 0 of -1. My degree is 3. I have 3 zeros. I have 3 factors. My factors and zeros are opposite. That's how that works. Now, if you didn't get 0 in the remainder spot, you can't go on. So you don't know any factors or zeros. So for the rest of the page, from 2 through 6, I want you to use synthetic division to find the remainder. The remainder is 0. I want you to go on and list all of the factors and all of the zeros. If the remainder is not 0, then I want you to stop. And that is the factor theorem.